Ladies and gentlemen, hello and welcome to our LinkedIn Live session today. Yours truly, Eric Kavanagh here, and I'm so pleased to be with two experts in the field of AI and machine learning and analytics, of course. We're going to talk about 7 analytics and AI trends that you need to know about in 2022 and beyond. We'll be hearing from Martin Willcox and Jean-Charles Ravon of Teradata. But mostly, folks, we want to hear from you. What do you want to learn today? What do you want to learn about AI, machine learning, scaling, all these different topics related to this brand, well, we'll call it brand new technology space, but it's newly important for sure. I was thinking to myself about the history of business and the history of technology. 1908 is when the Model T came out, and you could say that 2008, about 100 years later, is when these technologies started to take off. But today, folks, it's a whole different ball game. So we're going to hear about that from Martin Willcox and Jean-Charles Ravon of Teradata. We do have a couple white papers we'd like you to download, Analytics 1, 2, 3, and bring your own model. So we'll get to those later. And we will have Q&A throughout. So don't be shy. Send notes to us through the little chat message or the Q&A because we want to know what you want to know. But let's go ahead and dive right in. Martin Willcox, let's dive into the trends, 7 AI and analytics trends that you need to know about. Take it away.
Thank you, Eric, and good morning, good afternoon, good evening, everybody. It's great to have you with us today. So the first trend that we're going to talk about is machine learning as a commodity. So listen, many of you will have heard me say this before, but we're clearly on the cusp of an era of ubiquitous machine learning. We've got advances in technology that mean the unit costs of prediction are falling, even as the quality and the utility of the predictions that we're making are improving very rapidly. And we've also got digitalization initiatives that mean more and more processes are digitized, more and more processes are instrumented, capable of creating the data that we need to train even more and better predictive models. And the result in very many industries is this virtuous circle. And as the authors of one of my favorite books on this subject like to note, cheap changes everything, and cheap means everywhere. We did some back of the envelope maths for a large UK bank recently and concluded that they will probably need to score 100 billion predictive models annually in production within the next decade. And that's a vast increase, an exponential increase, a 2 orders of magnitude increase in the number of models that organization is going to score annually. And I think the clear implication is that those workloads will need to be managed and industrialized in a way that, frankly, they generally aren't today. And Jean-Charles, I know this is something that you think a lot about.
Yeah. Actually, Martin, machine learning, fundamentally, it's a tool to label data or derive a value, right? So you can forecast your sales, classify customers, identify any kind of risk. So obviously you can do this without machine learning, but reality is that now machine learning is doing that better and way faster than you are doing. So as you say, the price of ML has drastically decreased for the last decade, and research in that field is growing exponentially, and so capabilities. So think about it fundamentally as a tool that can accelerate data-centric product development. And so we can then assume that as ML is getting cheaper and better governed, a lot of labeling activities will be handed over to machine learning, as opposed to creating, complex rules manually. So a good example of that is the data quality practice, where you need to check all your data entities. And it comes at a huge cost because you need to define rules. And machine learning can do that for you with an outlier detection algorithm in a fairly automated way. So in short, that's now a simpler and more productive way to develop code.
Yeah, that's some pretty interesting stuff. And Martin, I know we got another one coming up here, number 2. But for number 1, you talk about cheap means everywhere. I wanted to quickly talk about that cost. And Jean-Charles, maybe you can comment on this. Different parts of the process have different costs in terms of the actual compute cost. It's my understanding that scoring the model is pretty cheap, but training the models, that's still pretty expensive. Can you cover that real quick, Jean-Charles?
Yeah, absolutely. So training of the model is in many orders of magnitude more expensive than scoring the model. So you need probably to leverage specific platform which are optimized for this. I'm thinking especially of so-called new fields such like image recognition, natural language processing. There is that example of OpenAI. So they have released in June 2020 the GPT-3 model, which has been estimated to cost of $5 million only for the training, not even talking about the skills you need to hire to perform those kind of training. So yes, training indeed is vastly more expensive than scoring, and you can do scoring actually very fast, and it's fundamentally the cheapest part of machine learning, which means that you can probably deploy that to your production platform and integrate directly scoring of machine learning models in your production platform.
Yeah, and when I mentioned Model T, the whole idea was the assembly line. And that's really what we're looking for, Martin, is an assembly line for building and scaling models and putting them into production and managing them and monitoring them. All of that stuff needs to be ideally automated as much as possible with the manual override in place, right? You want to be able to stop the line when something is going wrong, so you don't crank out models that are doing the wrong things. But the key is to automate as much as possible, right, Martin?
Yeah, I think absolutely, and your analogy is a really interesting one, right? Because in a lot of organizations today, machine learning is this artisanal process, right? You know, we've got experts that are handcrafting one data wrangling pipeline, one data wrangling pipeline for each machine learning process and model, with relatively little automation and relatively little focus on reuse. And actually, the focus on reuse is something at Teradata is that we're very passionate about. You know, creating curated collections of features with known predictive value and reusing those to train and score models in adjacent spaces, rather than going all the way back to the data lake every time to go and get more or less the same data to create more or less the same features to train really similar models.
That's right. Well, let's jump into number two then and talk about scaling. It's not just speeds and feeds, right, Martin?
Yeah, so I think, you know, it's increasingly clear. For us, trend two is this commentary about scaling. And I think it's increasingly clear that if we are serious about industrializing machine learning, then we have a scale challenge. And speeds and feeds are absolutely part of that scale challenge. But perhaps even more interestingly, there's kind of questions of organizational scaling. And I think we also have to be clear what we mean by scaling. So when we talk about scaling machine learning, we tend to talk about vertical scaling of machine learning and horizontal scaling of machine learning. And real quick, for anybody that hasn't been exposed to this kind of idea, there's a class of problems where in general you can get a really, really good predictive model by taking a relatively simple algorithm and training it on lots of observations. Churn and propensity models be a great example. We have a customer that trains new propensity models on 1 million observations, scores them on the entire adult population of the US, 250 million observations, and expects to be able to do that multiple times per day to support this kind of champion challenger working. So that's what we would refer to as vertical scaling of machine learning, if you like, this Google idea from about a decade ago about the unreasonable effectiveness of data. But there's a whole other group of use cases in our experience. Demand forecasting would be one, certain types of fraud prediction would be another, and John Charles is going to talk about that in a moment, where this kind of micro-segmentation approach is much more appropriate, where we increasingly want to create one model per customer or one model per store product combination. And that gives us some really interesting scaling challenges. We've got to be able to get data into the platform really quickly in order to be able to train models on an event-driven basis in near real time with response times measured in hundreds of milliseconds. And that is a speeds and feeds problem. But we've also got to be able to train and deploy and score potentially tens, hundreds of millions of models in production. And that's a scalability challenge that goes way beyond just speeds and feeds.
Mm-hmm. Yeah, and John Charles, I know you wanted to comment on that as well.
Yeah, so two good examples. So Martin, you have already stated demand forecasting. If you think about a retailer willing to reduce his waste and predict lost sale, you would have to do it at the most granular level if you want to be accurate. So the most granular level would be a product and store. So if you take into account that a standard supermarket has something like 30,000 products, and so for big retailers, this means 200, 300, 600, 1,000 stores. Simple maths will tell you that you will have to manage millions of models. And so it's absolutely critical in that case to have not only a robust machine learning workflow, but also the platform that can support it. Because once you will have produced your forecast, you will have to distribute those forecasts across the organization, supply chain, store operation, etc., etc. Another example, it's on a random access takeover fraud. So random access takeover fraud, it's basically when someone is taking control of your banking credential. And so generally, you can identify those kind of RRT fraud by analyzing the transaction. So you have outlying transaction, outlying behaviors. And so speed is absolutely key. So you need not only to have a model per customer, but also being able to score any transaction in near real time. So yeah, here again, that's a scale issue. But it's not on definite, as you said, it's not only about speed and feed here. It's also about crazy concurrency of the different execution. Also being able to manage millions of models. So yeah, pretty tough thing.
Yeah, we've learned a lot about distributed systems and federated systems and so forth, and certainly that's part and parcel to the cloud and the cloud taking over. We do have one fun question that just came across the transom. I'll comment on it quickly before we go on to number 3. An attendee writes, will AI take over the human race once it starts learning machine learning? I think the key to remember is that human beings will always be in the loop. And one of the fun terms I've heard that I think is very compelling and indicative of how to get value from these things is narrow AI. And the point is that when you apply machine learning or artificial intelligence, there's always supposed to be a very narrow, specific, granular focus. It seems to me that typically, and Martin, you kind of talked about this earlier, that there are 2 broad classifications or 2 broad groups that I see for applications of AI. One is optimizing a decision point, so predicting sales, predicting forecasting, and so forth. And the other is classification. Which group do these people go in? And that's really what these algorithms are doing, is they're doing one of those 2 things or a combination via some recipe, essentially, but there will always need to be a human in the loop, right, Martin?
Yeah, I mean, I think our CTO, Stephen Bropes, thinks a lot about this, and he likes to talk about augmented intelligence rather than artificial intelligence. And I think that's a pretty good way of thinking about it. You know, when you get all done, for all of the amazing advances, and there have been some amazing advances in machine learning and AI technology in the last decade, but when you get all done, when you look at how we're applying these technologies, and particularly in the B2C and the B2B industries, 90% of what we're currently calling artificial intelligence is really supervised machine learning, and nothing wrong with that, right? You know, if it's helping us to predict the quality of welds, to do preventative maintenance, reduce churn, etc., etc. But you know, 90% of what we're doing is really supervised machine learning, and the implication is that, you know, normally there's a human involved to help label the data or to ensure that the data has been labeled correctly. Normally there's a human involved to make sure that the output of the model makes sense and is reasonable, you know, and if we're smart, we've definitely got a team of humans involved to make sure that we're not indulging in algorithmic bias, that the predictions, the decisions that we're making are consistent with our values and principles and the way that we want to run the business.
Yeah, and you know, Jean-Charles, I'm going to throw a quick curveball over to you because a great question just came across the transom. Any views or perspective on potential false positives and false negatives and how AI can help us to avoid those altogether? And that kind of gets into one of my other big questions too, which is where do you place the markers when you're trying to understand in a continuum, what is the pattern? Is it a day? Is it a month? Is it a week? These things come into play too, but maybe focus first on false negatives and false positives, which do happen. How do we mitigate those, Jean-Charles?
Well, you know, AI machine learning is only replicating and accelerating some processes. Okay, so it's all about automation. Fundamentally, it will depend on your data. Okay, so if you are working on human generated data, there will be some errors, there will be some outliers, there will be some unspotted behaviors, such like, for instance, customers willing to buy certain types of product. So you can have probably a 80% hit rate, but you will always miss some of the people willing to buy that product. So on human data, you will always have a false positive and error rates. That's fairly different for machine generated data. So if you think about predictive maintenance, where you are using a lot of sensors data, so you know that from an engineering standpoint, that the data that is streamed by your sensors should be in a certain space. If you have some points outside that space, there might be a problem. So I don't think you will always have a 100% accuracy, and it will highly depend on how the data has been generated and which kind of topic you are working on.
Yeah, no, that's a good point. And real quick before we go on to number 3, Martin, another great question just came across the transom here. An attendee writes, machine learning is good at cost reduction. Is that the main advantage? I think that's one of the key advantages, but really optimizing predictions is a big part of this, and that's top line revenue as well, right? It's not just saving cost, it's making more money, it's making better decisions, it's collapsing processes or streamlining processes. All of these different things can be significant benefits from AI and ML, right, Martin?
Yeah, and I think just real quickly to come back on the previous question as well, this is another great example of why we still need a human in the loop. Very often for a given level of model accuracy, we can have more false positives and less false negatives, or vice versa, right? Making a business decision about which of those things we are most keen to avoid is another great example of where a human decision maker in the AI process is really important. If you look at the use cases that we see our customers solving with artificial intelligence and machine learning today, to come back to the next question from the audience, Eric, there's a bunch of stuff that's not exactly new. In some cases, the data sources that we're using to go after these problems are new. In some cases, the algorithms and the technologies that we're using to go after these problems is new. But it's the idea of reducing churn, the idea of targeting customers to cross-sell and upsell to, the idea of preventative maintenance. None of these things are exactly new, right? We've just got some better mousetraps to go after those problems. And a bunch of the problems that we see our customers going after are about reducing costs through optimization, right? Reducing churn, because it costs more to acquire a customer than it does to retain them. Reducing costs by improving uptime of machinery or equipment, etc., etc. So yeah, there are absolutely a group of use cases that are really about optimization. And whenever I hear optimization, I'm normally thinking about cost reduction. Not always, but very often. But I think there are also other use cases that really are about generating net new business as well. And thinking about how we can target customers for net new business and net new business lines as well. So I think it's probably true to say that very often we're applying AI and machine learning to reduce costs, but not exclusively.
Okay, good. Well, let's move on to Mlabs is the new black. I always love that expression. Tell us what that means.
Yeah, so I think it's really interesting to see Andrew Ng talking a lot in the industry recently. And Andrew Ng, for anybody that's been living on Mars for the last couple of years, I mean, he's arguably the godfather of modern machine learning, right? And he's been talking a lot recently about this idea of a proof of concept to production gap, about the idea that we're really good at doing well on a training data set in very many organizations, but often much less good at getting trained models into production where they can deliver value at scale and with pace. And as we scale to deploying millions of models in production, then we need to really think about that very seriously, right? Because now we've got to make sure not just that we can train very many models and deploy very many models, but we also need to think about how we manage those models through the analytic lifecycle. Because one of the dirty little secrets in the industry that we don't talk about so much is that these predictive models, almost all of them have a half-life. And particularly in adversarial situations like fraud detection, that half-life can be pretty short. So understanding which models we've deployed in production, where, at which version level, the quality of the predictions that they're making, whether the quality of those predictions is drifting or not, and by how much it's drifting, whether that implies that those models now need to be updated or potentially retired and replaced. This is a really important problem. And at the kind of scales that we can see that we're going to be operating at in the next few years, this becomes a really quite significant challenge. And again, it comes back to this idea that we have to have a whole new set of management frameworks and disciplines around the way that we deploy, monitor, and manage models.
Yeah, that's a very, very good point. And I'll throw it over to Jean-Charles to comment on that. What do you think about that, Jean-Charles?
Yeah, so I would say that machine learning is really becoming an engineering topic now, because you need tools to automatically detect issue with some of the models you have, defined triggers to retrain them, etc. So when a problem cannot be handled by the machine, so for instance, your trigger has retrained the model, and you still cannot reach a right level of accuracy, then you need powerful tools to investigate data set and some prototyping environment to test new features that could help you achieve a proper level of accuracy, right? So some are doing even machine learning on machine learning artifact in order to estimate the likelihood that a model will become less predictive in the future. And think about also anticipating changes in the data where some variables are evolving. So it could be because customer behaviors are changing. You might have not included all externalities in your current model. So you need basically a super robust model cataloging, industrial and automated model management, not to speak about the underlying engine capable to handle the massive amount of query and ML processes in high concurrency and high performance. So some call this analytics ops, some would call it model ops, some other ML ops, but regardless of the name, this is a critical capability now for organizations willing to scale machine learning. And that field is growing rapidly, actually, and several useful frameworks, tools, and technologies are already available, including one from Teradata, by the way.
Yeah, we're talking about automating the entire process. And when you think about that assembly line, I'll throw it back over to Martin quickly. When you have this MLOps structure in place, you have governance. You can roll back. You can explain things if someone comes knocking on your door and asking how this algorithm worked. We've kind of hinted at explainability, but knowing which model was in production where, that's going to help you optimize all sorts of things, like which models are working better, like which teams are doing a better job by maintaining records, so you can go back in time and see which models in production, which features were there. All of this sort of promotes reusability. Real quick, Martin, what do you think?
Yeah, and in fact, we're going to talk a little bit later about accountable AI as being one of the trends that's really important and that we need to care about. But you're absolutely right. This idea of understanding, if we made a decision on the basis of a prediction, what was that prediction? How did we make that prediction? Why did we make that prediction? Is really, really important. And I think the other thing that we talk a lot about at Teradata is that machine learning is a data problem, machine learning is a scale problem, machine learning is an operationalization problem. Going back to this idea that machine learning is a data problem and that we need to focus much more on reuse of data, reuse of features with known predictive value rather than recreating those features every time we train a model in an adjacent space. That means that the other trend that we haven't talked about actually today in this presentation, but the other trend that we need to care about is data ops. Data ops and analytic ops, or to Jean-Charles' points, I've called it model ops, some call it ML ops. But those two things are really, if they're not quite identical twins, they're definitely both very important, because it's a fine thing to do a better job of model management, and we're going to need to do an even better job of model management in the near future. But if we're creating one data wrangling pipeline for each model we want to deploy in production, then Houston, we still have a scale problem.
Mm-hmm. That's right. The scale problem comes in at every component along the process. So we want to automate as much as possible. And part of that is being open to new ideas, to new technologies, to new solutions. And that brings us to our next trend. Let's talk about open analytics. And Martin, you're saying this will be the next big thing. What do you mean by that?
Yeah, so listen, here's our core observation, and Jean-Charles will talk about this a bit more in a minute from a practitioner's perspective as well. But it's brutally hard right now for organizations to standardize on a single tool or a single technology for machine learning, particularly in our experience for model training. There are lots of really, really great tools. I mean, one of the fantastic things about all the innovation we've had in the last decade is there's been this explosion in tools. And a lot of those tools have very different sweet spots. So some of those tools are genuinely better for building models in some domains than others. And the other thing that's really important in all of this is, part of our scalability challenge is a time to market challenge. It takes too long in very many organizations, to go back to Andrew Ng's point about this proof of concept to production gap. It takes too long to build prototype models, and it takes even longer to get those prototype models into production in very many cases, because very often we train a model in one technology, and when we want to deploy that model to score that model in production, that means re-engineering it to run on another technology that we support in production. And it's also about skills. If we want to reduce that proof of concept to production gap, then we want to make sure our data scientists are productive as possible. And it's a really difficult thing, for example, in a large financial institution, very often to go into the risk department and say to 150 SAS programmers with decades of combined experience with SAS, hey, good news, we're going to standardize on Pandas, Python, and scikit-learn. And conversely, it's a really difficult thing to go into a group that's been working with those technologies for 5 years and say, hey, good news, the corporate standard is SAS. We don't make people more productive at that point. We make them less productive. Potentially, we're trying to turn every problem into a hammer, because we've got a bunch of nails. So we need to be able to support a range of tools. At this point in the industry, certainly, maybe there's some consolidation in a few years, who knows? But right now where we are, we need to be able to support a range of tools, particularly for model training. But that has two really negative consequences in a lot of organizations. The first consequence is that very often when we deploy multiple tools, each one of those tools comes with a redundant data silo to support the model training. And that's a TCO challenge, it's a technical debt challenge, in some cases it's a security challenge as well. And the second challenge, to go back to something we talked about earlier, is that we risk making the proof of concept to production gap bigger rather than smaller, because we're going to train models in a bunch of different technologies, but when it comes to get into production, we're going to need to rewrite those models, in some cases almost from scratch, for Java, for SQL, for whatever it is that we can support to deploy those models in production at scale. And so this idea of open standards to promote interoperability across technologies is, we think, an incredibly important trend in the industry right now.
Yeah, BYOM, that's one of the white papers, bring your own model, but bring your own technology too. Very quickly, Jean-Charles, that practitioners love their tools, and you don't want to be taking tools away from people if they're comfortable driving that particular version of the Model T, for example. So very quickly, you want to enable diversity of technologies, of practices within your organization, within reason, obviously, but you don't want to just close off and say, sorry, we're standardizing this tool, and make your users unhappy, right, Jean-Charles?
Yeah, definitely. And there are several good reasons for that. The first one is that you might want to de-risk your technology choice, right? And not rely on one single one. The second one is all about creativity. Data scientists need to find hidden pattern in a huge amount of data, and so this is fundamentally an activity for which you need to provide them with a blend of tools which might be specialized or better fit for this or that task. So we really don't believe that you should or you can constrain data scientists to use a limited set of tools. So this means that that you need to handle those tools diversity by providing interoperability at scale and be ready for the future, because obviously those tools will evolve and there will be new tools coming in the forthcoming years, right?
That's right.
So it might be seen as a challenge, but there are some good news here, because some organization, so for instance, the data science community and companies such like Facebook and Microsoft are working on model format that can enable such interoperability. I can state two of them. So the PMML model format, which has been released for the first time in 1998, which is quite a ride from here. And more recently, the ONNX model framework, which enable to interoperability for neural network-based model, but not only those models, by the way. So basically, it simplifies a lot the deployment and the way to put your model in production, as long as you can support those type of model. Obviously, it's what we call bring your own model fundamentally. So taking one model, putting it in a standard format, and then putting it in production on your scalable platform.
Yep, that's good stuff. Well, let's talk about where this is all headed. The cloud, right? Analytics is going to the clouds. Tell us about that, Martin, and why multi-cloud is here to stay.
Yeah, so listen, multi-clouds are a hot topic in the industry right now, and not just where we're talking about advanced analytics, machine learning and AI. I think, we were, Jean-Charles and I were lucky enough to be in a presentation from one of the Gartner analysts recently. And the Gartner research indicates that 80% of organizations already have a multi-cloud strategy, some by design and some by accident. And anecdotally, the Gartner guys will tell you that the other 20% of customers also have a multi-cloud strategy. They just don't know they've got a multi-cloud strategy. And we're pretty confident that this applies to AI and machine learning as well, right? Fundamentally, when we're talking about AI and machine learning, we've got model training and model scoring. And to the point that you and Jean-Charles were discussing earlier, the model training part of the process in particular, it tends to be associated with a more relaxed service level goal. And it also, from a computational and a TCO perspective, is also where a lot of the cost is bound up. So having the ability to kind of break the machine learning pipeline, break that process, and move different parts of that processes to platforms with different performance characteristics, but also potentially more importantly, different TCO, that we think is going to be really, really important.
Yeah, and Jean-Charles, you're going to be able to, you're going to want to be able to move around and to take different workloads and put them in different environments, to Martin's point, because you're going to find that GCP is good for one thing, Azure is good for something else. AWS, of course, has been around a long time. They got a head start on all those guys, but you want to be able to move. You don't want lock-in, right? So you want cloud native. Can you talk about that very quickly, what that means from an ML perspective?
So basically, as we said already, training of models can be insanely expensive, right? So when you are constrained to train those kind of models, you definitely want to have the freedom to select the most suited platform, which is the cheapest platform or the platform with the best performance on price ratio, right? So it can, by the way, the choice of the platform, the choice of the cloud provider can be a super complex topic, because price are changing a lot, configuration are changing almost every day. So this is a complex choice, but a complex choice that can really enables you to save a decent amount of money. And basically, I would believe that one of the best value of the cloud is that ability to deploy, kill, and redeploy an architecture or a platform in a matter of minutes. So why not taking advantage of it, to lower your cost and increase competition, right? So we see more and more machine learning engineer team setting up framework which enables them to deploy a platform just for the time of the model training, then grab the model, put the model into production, and then redeploy another platform on another cloud for another model, depending on the price and performance context for each of the cloud providers.
Yeah, that's a really, really good point. And we'll keep learning about that day after day. And this is the value of having a multi-cloud strategy is if your eyes are open and you're paying attention to the different providers, where they excel, where they have some issues, for example, you're going to really be on top of your game and able to leverage the best of breed in all these different cloud environments. And, you know, for number 6, we're going to get on to one that is one of my personal favorites. I'll throw it over to you, Martin, and I'll just throw a comment out about open source technology in general, which has really fueled much of the innovation that we see these days. And it was a rather dramatic shift from the sort of closed source world of days gone by. And one thing I love about open source, and we'll talk about this now with respect to NLP and some other things, is that you don't have to reinvent the wheel. Companies were spending so much time and effort reinventing wheel after wheel after wheel. And think about it. Who goes out and builds their own car? No one goes out and builds their own car these days. Someone may somewhere. You go and you buy a car that's already built because the motor companies figured that out and they've optimized that process. And the same is now true for some of these NLP models, which you can just rent. Why train your own when Google has done the work for you? But Martin, why don't you tell us about that?
Yeah, and exactly to your point, Eric. You know, we think one of the really important trends here is, and it's kind of, I guess, ties back to this idea of machine learning becoming a commodity as well. Particularly when we look at the application of, you know, sophisticated neural networks to what we might call unstructured data, or maybe more correctly, multimedia data, for things like natural language process, for things like entity recognition. You know, as much fun as it is to play with those technologies, the reality is that most of us aren't better at that than Google. You know, ultimately, entity recognition or sentiment analysis is not really, in the end, the problem that we're trying to solve in most of the organizations that we work with. Very often, what we're using those technologies for is to create features from complex multimedia unstructured data, features that we can represent as relational metadata that we're then going to take into another predictive model in order to make a prediction. Great example from a project that Jean-Charles was involved in recently. You know, we were using complex machine learning to create features from welding robots in order that we could then predict the quality of the weld. You know, the business outcome that we really care about is predicting the quality of the weld. And if we can use libraries of open source technologies and algorithms to do the analysis of the sensor data coming off the robot, why wouldn't we? You know, that is complicated stuff. And we absolutely don't want to be reinventing that if possible. What we want to do is to get features as quickly as possible that we can use to train a model to predict the quality of the weld. So this idea that increasingly we will reuse those libraries of algorithms, especially for the kind of AI for feature extraction tasks, if you will, we think is really, really important.
Yeah, and real quick, I'll throw it over to Jean-Charles about that. Feature discovery is my favorite part of this whole process, I think, just kind of understanding what are the features that are going to be indicative of predictive capabilities, et cetera. How big a deal is that from your perspective, and what's some advice you can offer to our attendees now about how they can do the best job they can in that regard?
So the first recommendation is to have a properly structured feature store, right? Because if a feature is valuable for one given model, you want definitely to reuse it to make it available for other models, because it might be very useful. So the first thing is to embrace, I would say, structuring the underlying data sets that you want to use for data science and machine learning through Enterprise Feature Store. Then once that feature store is structured, you can definitely automate the review of the variables in order to identify the best one, and those will be variable for different types of purpose. And then afterwards, I would say that it's the standard machine learning process where you tend to keep as little variable as possible by removing those who are correlated, and then produce a model which is cheap to maintain, which means that don't have too much features or keep only the useful one in order to create a prediction. And yeah, that's it. Yeah.
Okay, good. I'll throw it back over to Martin, maybe to bring us into the seventh and final trend. And folks, we should have some time for Q&A. We got a bunch of good questions that have come in so far. And you alluded to this already, Martin, but it is the elephant in the room, I suppose. Accountable AI, explainable AI. Certainly for regulated industries, that's a really big deal. We're going to need to have to explain these things. That means it can't be a black box, right? Tell us about accountable AI.
Yeah, and I think this is it's for sure a topic in the regulated industries, right? Why did we make the decision that we made? And we in most cases we can't just tell the regulator, well, hey, that's what the computer told me to do, right? That's not the right answer. That's not a good enough answer. But it's also a question of executive engagement and buy-in in some cases as well, right? If we're gonna when we're deploying machine learning and AI successfully, we're using it to change a business process, to change the way that we do business. And in general, somebody's got to sign off on that decision. And very often the person signing off on that decision is not a machine learning expert, is not an AI expert, right? And so this idea of accountable AI, of explainable AI, we think is really important. There's a couple of different dimensions to this. Partly it goes back to this idea of model management, right? Which model made the prediction, at what version of that model was it running? And being able to understand that is an important piece of the puzzle. Partly it's about data management, and in particular about bitemporal data management. Which data did we feed the model when we ran it at 10:21 Zulu on the 9th of March? If we can't recreate the input conditions, then we also can't recreate the output conditions. We can't recreate the prediction. But possibly more importantly, in the context of this particular trend, it's also about model interpretability. How do we understand why complex models are making the predictions that they're making? And so in model interpretability, we think is a really important trend in the industry as well, and one where there's been some really interesting recent progress.
Yeah, and Jean-Charles, maybe I'll throw that over to you. Explainability really gets into the weeds, and some of these deep learning models can have hidden layers, for example, and that's kind of where it all goes dark. But it is important to understand how the calculations are made, to understand what the like Martin said, which data set did we feed this algorithm at what time to generate this particular outcome. I mean, I've even heard of interesting companies that have deep learning modules that do nothing but try to understand what other deep learning modules came up with. So you can bring these technologies together to get a deeper understanding of how they work. And it's important to know how they work, right, Jean-Charles?
Yeah, indeed. So first and foremost, as you said, interpretability is really key. And it's not only key, it's just a good thing, right? Because you might have interpretability will give you the important variable that you that are the most important for your model. You can confirm some hypotheses. You can discover new patterns, new behaviors. Think about data mining. So those kind of techniques were applied to do data discovery and to understand the relation between the data entities. So first, it's definitely a valuable thing, right? And probably from my point of view, the most exciting one in that kind of job. But also interpretability. If you think about accountability, it's just mandatory now, or it will become even more mandatory, I would say. You have three pillars fundamentally to accountability. You have fairness, safety, and security. And so for fairness, so you want to check if your model is not discriminating, for instance, some groups of people. And you can define this only through interpretability to understand what your model is doing. And you might think that this is optional, but we are seeing more and more guidance, even from the European Union, arriving, and those guidance will probably be translated into regulation in the near future. So interpretability is important. And to your point, even for deep learning models, you would have to deploy those kind of interpretability framework. Here, the good news again is that such framework exists right now, such like Lime, and that can be integrated to almost any kind of machine learning process. So I would say that the two questions you would have to ask yourself is how I can integrate a robust interpretation method to my workload before someone nervous asks me to do so in the emergency. And the second point, if you have a lot of model in production, can your platform can not only cope with the huge number of machine learning model to execute, but also all the interpretability framework that you will have to put on top of each of those models.
That's a good point. And we have a very pointed question for you, JC. Can you offer any additional guidance that from the EU, or elaborate on guidance from the EU as regards these terms? Is there something that's going to happen soon, do you think? I mean, what I find interesting here is that if you're being responsible in your execution of these technologies and of this data, then you're already taking into consideration the kinds of things that regulators would want you to do. So just being a responsible person is kind of half the battle. But is there any other information you can offer in terms of perspective on the guidance from the EU so far on when we might expect to see some changes there?
So first, those guidance are available on the EU on the EU platform. So it's freely accessible, and the important thing is that those guidance are for information, for your wise information, right? So far. So, but we can definitely expect that some of those guidance, such like ensuring that the relation between features and the target, the goal of your model, is well understood. Also, understanding that the data sets that you are using to train your models are properly monitored, because machine learning model doesn't really like new scenarios. So if one scenario hasn't been framed by the machine learning model, you will have probably an undesired output when this new scenario will arrive in your data set. And ultimately, what it means, if a new scenario can generate an undesired outcome, you might have someone willing to provide that undesired outcome. So it seems very abstract, but think about predictive maintenance. Think about especially predictive maintenance for cars, for planes, etc. This is a really serious topic. So that forthcoming regulation is not for the sake of doing another regulation, right? It's to protect citizens, and I would say that that's very important. That all the machine learning community is becoming more and more responsible about machine learning usage and governance.
Yeah, that's a really good point. And folks, we do have some time left for questions. Thanks for sending in great ones already. Maybe tell us where you're from when you send your question in too. It's always fun to see where people are calling in from. But I'm going to throw a question over to Martin here. I've wondered to myself, we see ethics coming up time and again in conversations around AI, which I think is appropriate, because we do need to take a hard look at what we're doing with these technologies, how they operate, how they impact society, what is that whole virtuous circle, if you will, or vicious cycle if you go in the wrong direction. But do you see organizations having someone who is targeted and specifically responsible for ethics, a sort of ethicist, if you will, in the organization, who is just constantly looking at the models, how they're applied, what they do? Is that an actual role in organizations today, or should it be?
Well, I haven't met a chief ethics officer yet, Eric, but I do know a lot of chief data and analytic officers who take this topic very seriously. I think there's really 5 things we've got to think about, but the single most important thing, and it was articulated really well. I think the lady in question was the chief marketing officer at Qantas at the time. I forget her name, but she had a really simple rule when she was working with her team to use AI and machine learning, principally for marketing, for cross-sell and upsell in her domain. And she was, would we be okay if one of our competitors was doing this to a family member?
Oh.
And if you can't answer yes to that question, then just stop. Just stop the project, stop what you're doing, go do something else. And I think that's brilliant advice. And I think that's probably the golden rule. Rule number 2 is to go back to the model management topic. Make sure that you're clear about your objectives and that your objective isn't too creepy, that it passes that first test. Make sure that you've got the model management right. Make sure you understand which models were deployed where and when, and make sure that those models are instrumented and you're able to detect where those models are drifting. The third rule is get the data management right as well. So make sure that you can recreate the input conditions. If you can't recreate the input conditions as they were last week, last year, last month, then again, you've lost control of the model. You've lost control of that accountability. The fourth thing really then is to be as transparent with consumers, in particular in the B2C industries, about what you're doing and why you're doing it. And then, lastly, again, particularly in the B2C industries, maybe a little bit less relevant for that kind of B2B example that Jean-Charles was talking about, preventative maintenance in airline industry. But consider sharing the value from deploying this technology with consumers. Consumers are amazingly tolerant. We all carry one of these, right? Consumers are amazingly tolerant of these things where we're transparent about what we're doing and we're creating additional value for the consumer. So I think if you can pass the creepy test, if you can pass the model management test, if you can pass the data management test, if you're as transparent as you can be, particularly in the B2C industries with consumers, and if you share the value with the consumer, particularly in the B2C industries, then I think you're in pretty good shape.
That's a really good point. And Jean-Charles, I'll throw one over to you here. We got about 6 minutes left for our show, folks. Don't forget to download these white papers, bring your own model, and Analytics 1, 2, 3. Jean-Charles, it was about 4 or 5 years ago, I noticed something on my iPhone. I had a meeting coming up, and my iPhone sent me a message that said, your meeting is at this time. It's light traffic to get there. I'm like, light traffic? I work out of my house. But I had been going to a particular place to do some meetings. And so what's going on here? The iPhone was tracking my behavior and noticed that I usually go to this other location for meetings. That's an example of the consumerization of machine learning, right? Through my phone, underneath there was machine learning cranking away, noticing my behavioral patterns, and then throwing me what it thought was useful information. Well, I'm not sure it passed the creepy test, but I guess it kind of did. But that's a perfect example of consumerization of machine learning, right? It's everywhere. It's underneath a lot of the applications we're already using. So I think it's really important that people understand and appreciate that it is there, it is operational, it's working right now. And the more we understand what it does and what it can do for us, the better off we're all going to be using these technologies. But what do you think, Jean-Charles?
Yeah, absolutely. So machine learning and AI is just enabling us to be more efficient in terms of data development and or in our daily life. By the way, you might have also some ways of doing or applying machine learning, which would help to go through the creepy test. So, for instance, you were talking about the recommendation of your phone, telling you that it's light traffic, etc. So if it's done using the data of your cell phone, mixed locally with some data coming from traffic information, that's all right. Okay, the bot is working on your phone, and there is no data sharing, data transfer, and no one can know that you will leave your home at this hour and then reach your office at that hour, which obviously unacceptable from a data security standpoint. The counterpart is that you need to be super careful when you are using some customer information, and hopefully this will continue to be regulated, because you definitely don't want to have a freely accessible GPS information of everyone with their name, etc., etc. So it's also a matter of not only accountability, but a matter of responsibility. As Martin said, what are you trying to achieve, and should you achieve that, and the way you are doing it is also super important.
Yeah, that's a really good point. And I do want to recommend folks that you set up a discovery call. If you want to talk to one of the consultants from Teradata, they'd be happy to walk you through some use cases and get you some information there. And just one real last quick question. This is a tough one to handle quickly, Martin, but there was a question early on about classical computing and classical computing frameworks and technologies and processes, and what place do they have? I think it's a pretty interesting question. I don't think we should forget the lessons that we learned in the era of classical computing, and I don't think it's ever going to go away. But it is a sort of you want to use these things in tandem, right? Because we have all these legacy technologies now. We're bringing in machine learning to optimize things, but that what gets optimized is often classical computing frameworks. What do you think about that?
Listen, I think some of the newer technologies and some of the newer algorithms that we've got for things like entity recognition, for things like natural language processing, they're a gift. They just are. They are phenomenal, and there's even more innovation coming in the quantum computing future. But to go back to this observation earlier about 80% of what we currently call AI is really supervised machine learning. 80% of that 80% is still logistic regression, support vector machines, and some of the simpler and the tried and trusted techniques. And there is a very good case for preferring the simplest technology, the simplest algorithm, the simplest framework that gets you the level of accuracy you need for a particular production application. Simple means faster to train. It means easier to deploy. It normally means faster response. It normally means simpler to maintain. So we've really got to be careful about fetishizing complexity just to keep up with the latest, the cool, and the new, right? The objective is to deliver business value sustainably and quickly. The objective is not to pad our CVs with the latest and coolest stuff.
Don't fetishize complexity. That's a great way to end. Folks, please do download those white papers, Analytics 1, 2, 3, and bring your own model and reach out for a consultative conversation. I think you'll be glad you did. Thank you so much for your time and attention. Thanks for these fantastic questions, folks. They really help us get you good content. We'll talk to you next time. The third one is coming up pretty soon. Take care, folks. Bye-bye.